at section 3. We'll get more derivative rules. The derivative rules that I'm going to derive today are going to be the 6 trig functions, and I'm going to derive the sine and the cosine using the definition of the derivative, and then I'm going to derive the other ones using the quotient rules. And I'll make a list of them all over here. We're going to have the derivative with respect to x of the sine of x, the derivative with respect to x of cosine, tangent, and 1 over the sine is the cosecant. 1 over the cosine is the secant. And then 1 over the tangent is the cotangent. And then I'll add the derivative of the natural log of x and e to the x to this. Yeah, so you can't see that at home. Tough luck, huh? I'll put them here though. I'm going to do this with the definition of the derivative. So you can kind of watch this first part. You're not responsible for being able to do this yourself. Just the end result is what's important. So for f of x is equal to the sine of x, f prime of x is the limit as h goes to 0 of the sine of x plus h minus the sine of x all over h. So what I use there is that the derivative is our definition. I use that. Do you see how that applies there? This does have the form of 0 over 0 as h goes to 0. So I got to do more. And with trig, the doing more involves using a trig identity for the sum of 2 angles. So I'm going to say that I'm using a trig identity here. The trig identity is the sine, say, of a plus b is not the sine of a plus the sine of b. It's a big old deal, big old looking expression. Let's see if I can remember it. I think it looks like the sine of a cosine of b plus the cosine of a sine of b. So when I expand this out, it's going to look like the limit as h goes to 0. It's the sine of the first, cosine of the second, plus cosine of the first, sine of the second. And I got the minus sine of x out on the end, and then I've got the h. And now I've absolutely forgotten what I want to do next. I'm going to add 0. Let me figure out how I'm going to add 0. gonna peek. I have absolutely forgotten this proof. How does that happen? I've done this 1,000 times in my life. Oh, I'm not gonna add 0. I'm just gonna leave it as it is. I'm gonna take that, and I'm gonna move furniture. I'm gonna move that over here. And then put that on the end. Just shuffle terms. And I'm going to shuffle terms. There's the H. Because that makes these two terms have a common factor of a sine of x. So from those two terms, I'm going to pull out the sine of x. And I'll be left with the cosine of h minus 1. And over here, I'll just leave it like that. They're all divided by h, so I can make two separate fractions. I can say that one and that one. And now this has nothing to do with h, so I can pull it out front, put that limit in here. Take this limit to the sum, pull that out front, put the limit there. And it'll look like this. Cosine of x out, put that limit here. The two things I have in the brackets are your two special limits from chapter 2. Like the first one's written instead of 1 minus cosine over the variable. I got it the other way, but that doesn't matter. Because if this were the other way, what's the value of that limit? It happens to 1 minus the cosine of an angle over the angle as the angle goes to 0.
Don't the A and the A can.
They don't cancel. It's 0. That limit is 0. And so if I swap the sign, it just makes it minus. Minus 0 is still 0. So this looks like sine of x times 0. So that's gone. The other special limit was the sine of h over h as h goes to 0.
1.
That one's 1. So there's your derivative of the sine of x. The derivative of the sine of x is the cosine of x. The derivative of the sine of x is the cosine of x. So I'm going to do the same thing again, but I'm going to change this now to a cosine. So I'm going to write this as the cosine of x plus h minus the cosine of x over h. All of these rules will be different. So let me rub off everything. Got a cosine. And all of that's going to be different. I have to look at a different identity. So if that's the cosine of x, then f of x plus h looks like the cosine of x plus h, and then f of x is the cosine of x. This time, the identity we use is for a cosine. The cosine of the sum of two angles goes cosine, cosine, so cosine first angle, cosine second angle, minus sine, sine. Sine of the first angle, sine of the second angle. So when I expand the cosine of x plus h, I get the cosine of x, cosine of h, minus sine of x, sine of h. So that's the expansion of the first term, and now I've got minus the cosine of x here. And then all of that's over h. If I want to do the deal with the common factor, I've got to move this to the middle again so that it matches up with that one of the common factor. H. All I did is move the last term to the middle term to the last. Now I'm going to factor out the cosine of x just between these two terms. And I'm going to have a cosine of h minus 1 divided by h. I'll go ahead and skip that step and move that in there. Then over here, we have minus the sine of x and the sine of h divided by h. And let's go ahead and take the limit. This is the one whose limit was 0. This is the one whose limit was 1. So we get the cosine of x times 0 minus the sine of x times 1. And we're left with minus the sine of x. That's the derivative of the cosine. The derivative of the cosine is minus the sine of x. So their derivatives are each other, just that the derivative of the cosine spits out a minus as well. The next one I want you to do, I want you to write the tangent of x as the sine of x over the cosine of x. And I want you to do the quotient rule. No more identities here. No more definition of the derivative. For f of x is equal to the tangent of x, write it as the sine over the cosine, and do the quotient rule. Bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So while I erase, I'd like you to do that part using your brand new derivative rules here. Then after you use the quotient rule, look at the numerator there. Look at the numerator you get. You recognize anything about it? No? Is somebody's rule, right? Somebody's identity. Sine squared plus cosine squared is 1. This is named after Pythagoras. Pythagorean identity comes out on top. All right, so here's what you get. Bottom is the cosine of x. The derivative of the sine of x is also the cosine of x. So there's bottom times the derivative of the top. Minus the top is the sine of x. Derivative cosine is a minus sine of x. Bottom squared, let's just write that as the cosine of x squared. When we square the trig function, we put it next to the word. So the cosine squared of x means cosine of x in parentheses is squared. When I multiply out the top, Cosine times cosine is going to give me a cosine squared. A negative times a negative gives me a positive. And remember, I can't cancel this term with that term just because they look alike because of addition. We can't pick any of our favorite terms in addition and cancel. We can only cancel in a product. So instead, I want you to recognize the Pythagorean identity. Cosine squared plus sine squared is 1. So I get 1 over cosine squared. But there's a trig function that is 1 over cosine. Which trig function is 1 over cosine?
Yeah.
Secant. So 1 over cosine squared is secant squared. And that is the derivative of the tangent. The derivative of the tangent of x is secant squared of x. So you get to do the quotient rule again for f of x is equal to the cosecant of x. Cosecant is 1 over the sine of x. So let me give you a moment here to do the quotient rule on that fraction. That part shouldn't take long. Here goes the quotient rule on that fraction. Bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. That first term is multiplied by 0. So I just have minus cosine of x divided by sine squared of x. I'm going to write that like this. Here's the minus sign. I'm going to take the sine squared and write it as sine times sine. I'm going to pull one of those out here, and then the other one here. Those two fractions multiply together to give you the same fraction as the line above, but I wrote them like that because now we have trig identities. 1 over the sine of x is the cosecant of x. Which trig function is cosine over sine? Cotangent. So the derivative of the cosecant is a minus cosecant of x times the cotangent of x. You're going to see that the derivative of the secant works almost the same way. You're going to do the quotient rule again, but secant is 1 over the cosine. You're going to get some version of this, and I want to see if you can separate that into the product of two fractions which match identities that we know. Starts out the same way, bottom times the derivative of top gives me cosine of x times 0. minus the top times the derivative of the bottom. Derivative of cosine is minus the sine of x all over the bottom squared. So it's that product in the front gives us 0. Let's get rid of it. Then I've got a pair of minus signs, so I can write that product at the end as a positive sine of x. So I'm going to take out one of the cosine squares and write it by itself. And then the other one underneath the sine. And there's two trig functions that we know and love. Whenever cosine is the secant, sine over cosine is tangent. Derivative of the secant is the secant of x times the tangent of x. One more quotient rule. Let's write the cotangent as cosine over the sine and do the quotient rule. Let's write the cotangent of x as the cosine of x over the sine of x and do the quotient rule. Okay, bottom times the derivative of the top gives me sine of x. Derivative of cosine is a minus sine of x. Bottom derivative of the top minus the top times the derivative of the bottom. It's going to give me another cosine in here. All over the bottom squared. So when I simplify that, I get a negative sine squared of x and minus cosine squared of x over sine squared of x. I can pull out a factor of -1, and that changes the sign there, and that gives us a 1 on top again. And so we get -1 over sine squared. 1 over sine is a cosecant. So the derivative of the cotangent is a negative cosecant squared. Now I'm going to kind of go over this list to show you how easy this is to remember. Sine and cosine, tangent and cotangent, secant and cosecant. Those pairs are co-functions. In trig, a co-function is something that takes on the same values, but of the opposite acute angles in a right triangle. But if you look at the co-functions, their derivatives look alike. The derivative of a sine is a cosine, derivative of cosine is a sine. The derivative of a tangent is a secant squared. The derivative of a cotangent is a cosecant squared. The derivative of a secant is secant tangent. The derivative of a cosecant is cosecant cotangent. Cosecants and cotangents show up together. Secants and tangents show up together. Those are all easy to remember now. Also notice that any of our trig functions that begins with the letter C, cosine, cotangent, cosecant, all have a minus sign in front of them. The other ones don't. Any trig function that begins with the letter C will have a negative. The secant and the cosecant both have themselves in it. And then their other trig function is what they're always related to. Cosecants go with cotangents. Secants go with tangents. Tangents and secant squared, they look the same, right? Tangents go with secant squared go with cosecant squared. If you remember the Pythagorean identities, there are the sine squared plus cosine squared is 1. There are 2 other versions of it. The tan squared plus 1 is secant squared, and cotangent squared minus 1 is cosecant squared. So they go together just the way they did in trig. Yep, they do. Okay, so let's try some examples. Here's some examples for you. Find number 1, the derivative find the derivative of x to the 4th times the sine of x minus 2 times the cosine of x plus 4/3. Let's see how to exit. Well, I didn't do that. None on here says exit. Let's look at that. Oh, you stupid thing. All right, so if you can take the derivative of this, starting here, what do you think? Product rule right here. Hold the 2, take the derivative of the cosine. What about the derivative of 4/3? Good, do it. Take the derivative. Product rule in that first batch. 2 times the derivative of the cosine in the second batch and 0 in the end. Sure on that first batch. They are all happy again. There's like 2 happy times in one day. What's going on here? All right, here comes the product rule. I do the first times the derivative of the second. So there's the first, the derivative of the sine of x is right up there, cosine of x. Then the other way, second times the derivative of the first. And then the derivative of x to the 4th is 4x cubed. Next one, I can copy the 2 down and take the derivative of the cosine of x. Derivative of cosine of x is minus the sine of x. And then finally, the derivative of 4/3 is 0. Now I'm going to write without all those parentheses. We typically put the polynomial term in front of the trig function. It makes it easier to read. So this one, I'm going to write that as x to the 4th times the cosine of x. I'm going to put the 4x cubed in front here and get rid of all the parentheses. 4x cubed times the sine of x. Put these two minus signs together to give me a +2 sine of x, and I don't need to write the 0. Are you good with that? All right, here's your second one. Take the derivative of f of x, find f prime, if f of x is the tangent of x plus x all over the secant of x plus 1. Give me a little quotient rule action here. Tangent of x plus x divided by the secant of x plus 1. I don't know if it's worth simplifying, so just take the derivative and let it sit there. That was the quotient rule. You knew that. So the bottom, secant of x plus 1, let's put it in the parentheses because it's two terms. The derivative of the top. You see the tangent of x, it has as its derivative secant squared of x. And then the derivative of this x gives me a plus 1 in there. Now the minus sign, copy down the top. Tangent of x plus x times the derivative of the bottom. The first thing we see in the bottom is a secant of x. So we go over there and look at the derivative of the secant of x, and we get secant of x times the tangent of x. And the derivative of that one is 0.
Wait, would that not go? Why would that go down there?
Oh, it doesn't go there, it goes right here. What goes down there?
Secant x plus 1 squared.
There you go. I don't know that it simplifies nicely, so let's just leave it there. Just remember that even though these two look alike, they don't cancel because of this. Okay. All right, find the second derivative of the cosecant of x. Second derivative of the cosecant of x. Label your derivatives. Where the first derivative starts and stops, and where the second derivative starts and stops. first derivative is a gimme. You just go over here and you'll see that the derivative of the cosecant of x is minus the cosecant of x times the cotangent of x. When you go to take your second derivative, what do you recognize that you need to do? You've got to do the product rule. So I'm going to emphasize that I'm going to do the product rule where there's my first and that one's my second. So in the product rule, we got the first times the derivative of the second. The derivative of the cotangent is minus cosecant squared. And the other half of the product is plus the second, that's the cotangent of x, times the derivative of the first. The first term is negative, and its derivative is going to be negative. So the end result is a positive. The derivative of cosecant will give me a positive cosecant cotangent. As the sign was negative here, and its derivative was negative. So that's why I just wrote a positive cosecant cotangent in there. Then to simplify this, I'll put those two together and get a positive cosecant cubed. Wow, give me an S here. Positive cosecant to the third power. And then I'm going to have a cotangent squared times a cosecant. And then we can just leave it right there. Okay. Let's add two more to our list. I can derive these again using the definition of the derivative, but I'm not because of the pressingness of time. And also because they're real easy to remember without having to go through the derivation. The next one is that the derivative with respect to x of the natural log of x is 1 over x. And if you think that's easy to remember, look at this one. The derivative with respect to x of e to the x is e to the x. E to the x is the only function in this world and in all other worlds whose derivative is itself. The derivative of e to the x is e to the x. Boom, easy. And then another way to help you remember that, when you graduate in 4 years and you shake the president's hand, the president is a mathematician. He's going to find out that you studied engineering or math, and he's going to say, hey, what's the derivative of e to the x? And you're going to tell him, or you're not going to get your diploma. What's the derivative of e to the x? What's the derivative of 5 times e to the x? 5 e to the x. All right, look at y'all. Okay, so let's do some of these. Let's take find f prime of x if f of x is equal to e to the x divided by x plus the natural log of x. Do the quotient rule for me. Ready? Using the quotient rule, we've got bottom times the derivative of the top. Hey, what's the derivative of the top? Man, you guys are on top of it today. Now minus the top times the derivative of the bottom. All right, what's the derivative of the bottom?
1 + 1.
All over the bottom squared. Good? Really nothing worth simplifying here again. Okay. How about you write an equation of the tangent line to the graph of f of x is equal to 5e to the x times the tangent of x at the point where I'm gonna make that a secant of x. Let's make that a secant of x instead of a tangent of x. E to the x times the secant, 5e to the x times the secant of x at the point where x is 0. So if you're writing an equation of a line, you're going to need the slope, the x1 and the y1, and all I've given you was the x1 is 0. You're going to find the other two attributes of this line. So, how are you going to get the slope? Derivative. Take the derivative, and then you're going to replace x with 0 after you take the derivative. So somewhere in there, you're going to have to know what e to the 0 is and what secant of 0 is. What's the secant of 0? Secant is 1 over cosine. Cosine of 0 is? Cosine of 0. Cosine of 0 is 1, so secant of 0 is 1. Tangent of 0 is sine over the cosine. What's the tangent of 0? Tangent of 0 is 0. You're going to need that eventually, because the derivative you're finding using the product rule. So here's your first term, and here's your second term. So we have the first times the derivative of the second. Derivative of secant is secant of x times the tangent of x. Plus the second times the derivative of the first. What's the derivative of the first?
5e.
5e to the x. So now we need this at x is 0. So we have 5e to the 0 secant of 0 tangent of 0 plus the secant of 0 times 5e to the 0. Any number to the 0 power is 1. So e to the 0 is 1. That gives me 5 right here. Secant of 0 is 1. Tangent of 0 is 0. So that first batch just multiplies to 0. Secant of 0 is 1. E to the 0 is 5. So I'm getting a slope of 5. Then we need f of 0 because that's going to be our y1. F of 0 is 5e to the 0 secant of 0. So it's 5 times 1 times 1. So f of 0 is also 5. And now we go to the point slope formula. Y minus y1 is equal to m x minus x1. We found the y1 just up there a second ago. That's that 5 over there. M is that 5. And x1 is 0. Whatever rearrangement you want of that is fine with me. That okay with you? Okay, now I kind of want to do kind of like an embedded derivative. Find y prime if y is equal to x squared e to the x all over, I don't know, sine of x plus the cosine of x. So what I want you to see about this thing is that it looks like a fraction. So gosh, you can take the derivative using the quotient rule. But when you take the derivative of the top, what do you notice about the top term? It's a product. So within your quotient rule, when it's time to take the derivative of the top, you got to do a product rule. All right, so do it. Do it real quick. We're running out of time, so do it real quick. Quotient rule, but in the derivative of the top, you've got to do a product rule. And again, don't simplify your answer, just let it slop all over your page. All right, I got to catch up with you because we're running out of time. Here's the quotient rule. Bottom times the derivative of the top. Here's where we do a product rule. First times the derivative of the second plus the second times the derivative of the first. And I'm going to go ahead and put that in front. Is that okay for you? Sorry, knocked you out. First times the derivative of the second, second times the derivative of the first. So that's bottom times the derivative of the top. Minus the top times the derivative of the bottom. The derivative of a sine is a cosine. Derivative of cosine is minus the sine. All over the bottom square. Is that good for you? So here's my challenge. By next time, have these 6 memorized. So I won't have them on the board, we'll have to take the derivatives without having to look them up. I think I have a web work for section 3 up already, but I'm not sure. I'll go check here in a minute. Get caught all up with your web works. Camera out of here.